Hello, this is Moresh, and we are going to continue our Arduino series again today. And today we are going to do the LED blink thing again. But unlike last time where we were actually using the LED on the Arduino, we are going to have a separate LED. So this is the same principle which we are going to use for driving any other peripheral, which can be a motor, which can be a pneumatic device, or anything else. So if we can drive an LED, then we can pretty much make the Arduino control any other peripheral as well. So we are also going to introduce some other things, which is the Thinkercad, which is an easy enough tool which allows us to simulate what your circuits are going to be like. So I've already created the circuit over here. Now this is an LED. An LED has, I'm going to delete this and that way I can show you. LED has two legs, one which is the long leg and this is the short leg. Now I couldn't remember earlier on which one is the positive one and which one is the negative one. The long leg, which is the anode, is the positive one and the short leg is the negative one. And an LED is basically short for light emitting diode. And why LEDs are special is because not only do they emit light, but they are also a diode. What is a diode? A diode is a one-way circuit. It's similar to a valve which only allows flow of electricity in only one direction. So if electricity goes like this, it cannot go back the other way. It's not relevant for our particular thing, but I just thought it would be cool to know. You have valves everywhere. You have this in plumbing taps. You can have it in even in our heart. We have one-way valves. So this is just an analog for that. Now this is a resistor. We are going to connect it with the LED. Why? Because if we power the LED directly with the power which is coming even from the Arduino itself, it could burn it. So the resistor basically takes some of the current away. I'm going to make this smaller so that you can see my pretty face. The resistor reduces some of the current, which means that the LED is not going to burn out. So what we are going to do, as usual, we are going to go to our trusty AI and ask, can you give me a wire diagram to blink a blue LED light? I'll just move this a little bit and you can see this with a 330 ohm. Now, ideally you should be using a 220 ohm resistor. I did not have a 330 ohm resistor. Ohm is basically a measure of resistance, just like how you measure speed in kilometers per second, etc. Ohm is how you measure resistance. Resistance, as the word suggests, is the resistance. It stops, it resists the current from moving, it reduces the current. That way our LED is not going to burn out due to too much electricity coming through it. So it's coming from the pin 8 to the 330 ohm. So what we are doing over here, this is pin 8 and I'm going to connect pin 8 to our resistor. There we go. And then we are going to connect it to our anode and then we are going to connect the cathode to ground. And that's pretty much it. It's a very simple circuit. Again, we are going to go very slow step by step so that you understand it. And then we are going to ask for a code which we have over here. I'm going to copy it and I'm going to go over here. I'm going to put it in code and I'm going to paste it. And now I'm going to start the simulation. This allows us to simulate without actually doing it physically. Once we know that this works, we can then do it physically as well. It's initializing. And as you can see, the LED is now blinking on and off, on and off. We can make it go faster. We'll stop simulating. Now let's make it go faster. 100 milliseconds. Let's start simulating again. It should blink faster now. Initializing. See, it's blinking faster. Now, let's take this away and we will switch our cameras to the actual circuitry. There we go. So we are going to replicate the same thing. And what we have over here is we have our trusty Arduino. We have a resistor and we have the LED. The blue, this is a blue LED. The long leg is the anode. The short leg is the cathode. Now let's start connecting it. And we also have this thing which is called as a breadboard. And it's called a breadboard because it kind of looks like a bread, but it is a very trusty tool which is used in experimental circuitry. Now what you see over here, these columns are connected. So if you connect a wire over here, it's the same as connecting the wire over here on any of them. So it makes it very easy to make connections. So they are connected vertically over here. These ones are vertically connected and these are connected horizontally. So any of these ones you connect over here, then you can connect another line in this hole, connect another line in this hole, and it's the same as connecting them together. And same as connecting the columns together. These are columns. These columns are not connected, but the columns are connected within this section. All right. So and these are just some wires. So what I'm going to do is I'm going to take the LED. So we are going to take this LED, we are going to put it in the breadboard. Let's put it somewhere here. And remember, we have to put it across. We can't put both legs in the same column. They have to go across columns. Otherwise, it's the same. Because the columns are connected together, it will basically mean that we are shorting it. So what we are going to do is we are now going to take this resistor. It is a 330 ohm resistor. The lines which you see over here on the resistor, they are used to tell what is the actual rating of the resistor. There are bigger resistors, smaller resistors. The colored bands tell us what is the rating of the resistor. All right. So I'm connecting this over here. I've connected the resistor to the longer leg, which was the anode. And now what I'm going to do is this leg over here, I'm going to put a wire over here and I'm going to go and find pin number 8. Where is pin number 8? It's far away. Let's see. This is 8. All right. So I've connected pin number 8 and then I'll take another wire and I'll connect it to ground. Where is ground? All right, I see it. Second pin. No, not there. I can see from here. All right. Now we have connected the wiring of it. I'm going to take the same code over here. I'm going to copy it and I'm going to open our integrated development environment, which is the Arduino IDE. It will open up. I'll minimize this and I'm going to paste this over here. And now do you see this cable over here? This is how this is connected to my computer, to the USB-C port. And now I am going to upload the code over here. All right, let's make sure it connects properly. Sometimes it just the simplest thing is somehow disconnecting and connecting the wires. All right, something's happening. There you go. The LED is blinking every 100 milliseconds. That's fun stuff. Disco lights. And now let's see if we can make it go slower every 1 second. We just add this another 0 over here, which means instead of every 100 milliseconds, it will blink every 1 second. So let's make it even slower. 3. So again, the code is more or less similar to what we had last time. Instead of pin number 13, we are using pin number 8. Let's go. 1, 2, 3 every 3 seconds. And let's go back to my pretty face. And that's pretty much it. This was our simple LED blinking sketch, but this is materially different than last time because last time we were not actually interfacing it with another device. This time around we have started introducing peripherals, which is starting with the LED. I'll do one more of these but with a micro servo motor. So you can see it can't just do on and off lights, but it can also move things. And then you can see how we can programmatically start making a bit more complex things. So that's it for today. This is Moresh. I'm going to include all of the sketch and all of the details, the wiring diagram, etc. in the description and have a link for that so that it becomes easy. If you have any questions or comments, please post it here. I'll try my best to answer them. Till then, bye-bye.